experiment turns waste CO2 to stone. Scientists think they have found a smart way to constrain carbon dioxide emissions. Just turn them to stone. The researchers report an experiment in Iceland where they have pumped CO2 and water underground into volcanic rock. Reactions with the minerals in the deep basalts convert the carbon dioxide to a stable, immobile chalky solid. Even more encouraging, the team writes in Science magazine, is the speed at which this process occurs, on the order of months. Of our 220 tons of injected CO2, 95% was converted to limestone in less than 2 years, said lead author Jörg Matter from Southampton University, UK. It was a huge surprise to all the scientists involved in the project, and we thought, wow, this is really fast, he recalled on the BBC's Science in Action program. With carbon dioxide concentrations in the atmosphere marching ever upwards and warming the planet, researchers are keen to investigate so-called carbon capture and storage (CCS) solutions. Previous experiments have seen pure CO2 injected into sandstone, or deep, salty aquifers. Chosen sites, which have included disused oil and gas wells, have relied on layers of impermeable capping rocks to hold down the carbon dioxide. But the fear is always that the CO2 could find a way to leak back out into the atmosphere. The CarbFix project on Iceland, on the other hand, seeks to solidify the unwanted carbon in place. Working with the Hillashidi geothermal power plant outside Reykjavik, it combined the waste CO2 with water to make a slightly acidic liquid that was then sent hundreds of meters down into the volcanic basalts that make up so much of the North Atlantic island. The low pH water, 3.2, worked to dissolve the calcium and magnesium ions in the basalts, which then reacted with the carbon dioxide to make calcium and magnesium carbonates. Cores drilled into the experimental site pulled up rock with the telltale white carbonates occupying the pore spaces. The researchers also tagged the CO2 with carbon-14, a radioactive form of the element. In this way, they were able to tell if any of the injected CO2 was leaking back to the surface or finding its way out through a distant watercourse. No such escape was detected. This means that we can pump down large amounts of CO2 and store it in a very safe way over a very short period of time, said study co-author Martin Stute from Columbia University's Lamont Doherty Earth Observatory, U.S. In the future, we could think of using this for power plants in places where there's a lot of basalt, and there are many such places. Dr. Matter added, you can find basalts on every continent and, certainly, you can find them offshore because all the oceanic crust, so below the sea floor, is all basaltic rocks. In terms of the availability of basaltic rocks to take care of CO2 emissions globally, no problem.